This is quite an old NCEA question, but it illustrates all the things that we need to remember about Hooke's law. So let's just write the heading, the duty-free shop, mainly because that helps me find the videos when I'm looking for them to post onto the slide. So at a duty-free shop at the airport, a toy teddy bear is hanging at the end of a spring. The spring is 51 centimetres. And that then stretches to 72 centimetres. So we've got a spring extension of 21 centimetres or 0.21 of a metre. Really important that you convert your centimetres into metres. And then the other thing that we need to know is that the mass of the teddy bear is 400 grams or 0.4 of a kilogram. And let's just calculate the weight force in case we need to use that later. 0.4 times 9.8 is 3.92 newtons. Okay, so we've got a spring extension, we've got a mass, and we've got a weight force there. Hopefully we've got all the things we need to be able to answer this question. So part A says calculate the spring constant and write a unit with your answer. So here is the formula for spring constant, F equals minus kx. Now this minus, a lot of the time you can ignore it because the minus is there because it's talking about the direction of the force, whereas the spring constant will just have a positive number. So quite often we can just ignore that. So, and in this case we can, so we can ignore the negative because we just need to ignore the negative. Okay, so we've got a force of 3.92 equals K times 0.21. So I'm going to divide both sides by 0.21. And that's going to give me K. And when I work that out, I'm going to get 19 newtons per metre. So we've got the force on the top, which is newtons, and we've got our spring extension on the bottom, so that's where that -1 comes from. So newtons per metre is the unit for spring extension. And that is, in 2007, that was worth a merit. So then moving along here to part B, we have to then calculate the energy stored in the spring when a second toy of mass 300 grams is also hung along with the teddy bear on the spring. So now we have a mass of 400 plus 300, 700 grams or 0.7 kilograms. And our weight force is 0.7 times 9.8. It's a bit tricky to do in my head, to be fair. 0.7 times 9.8, 6.86 newtons. And we are calculating the energy stored. We know the spring constant this time is 19. I might just actually check that, make sure that I haven't rounded too soon. 3.92 divided by 0.21. And it's actually 18.666 recurring, so that's the number that we should be using here. And our elastic potential energy is 1/2 times kx squared. So we're going to do 1/2 times 18.666 recurring times, what's our spring extension? How are we going to work that out? We need to work out proportionally the difference